So this is the second part of the video for lesson 2.4. Remember the first part we talked about the different forms of writing linear equations. Standard form, which was a review from lesson 2.2. But we also talked about slope-intercept form here in the front, and then point-slope form when that was useful. Now we're going to move to the second part of this lesson, talking about parallel and perpendicular lines. Hopefully you remember some of the facts from back in Algebra 1. And let me grab my highlighting tool. Parallel lines and perpendicular lines. First of all, parallel lines. Two non-vertical lines are parallel if and only if they have the same slope. The slopes would be the same. So look at this line here and this line here. In this equation, 2 is the slope. In this equation, 2 is also the slope. So the slopes will be the same. Now the second part, perpendicular lines, two non-vertical lines, okay, are perpendicular if and only if the product of the slopes is -1. What? Well, let me ask you this. What kind of numbers can you multiply together to equal +1? And the answer is reciprocals. 3/4 times 4/3 is 12/12 or 1. So how would you get -1? You're actually going to use the reciprocal, but the opposite of that. So it's a negative. If you want to get a -1 for answer. So let's take a look at the slopes here. The slope of this line, let me grab my yellow. So here we have this line here and this line here. They're perpendicular. How do we know that? Well, they look like they form a right angle. But more importantly, it's not how they look, it's their slope. So let me hit the green here. 3 is the slope of this line. -1/3 is the slope of the other line. And notice 3 and -3. If you take the reciprocal of 3, put 3/1, you then flip it. This is the way you flip it, right? 1/3. And the opposite of 1/3 is a -1/3. So we call this another way to say this is, right in the notes, it's the opposite reciprocal. Yikes, let me erase that, pause it, and then write it in there so it says opposite reciprocal. So you can see what I wrote here. I should have just used the text tool, but a fancier way, or to me a better way I understand it is perpendicular lines, their slopes will be opposite reciprocals. If you would end up going and multiplying 3 times -1/3, you get a -1. So opposite reciprocal is the best way of remembering that. Parallel lines have the same slope. Let's take a look at a couple examples. All right, in example 4, it asks us to write an equation in slope-intercept form for a line that goes through this point, 5 and -6, we know one ordered pair, and it's perpendicular to another line that has this equation. So we know one of the points and we know the slope. Since we know the slope, we could use, in this example, they're using point-slope form. They're going to fill in the slope, which is -3/2. However, they don't use -3/2. Notice they use the opposite reciprocal. -3/2 would be +2/3 because we're looking at perpendicular lines here. Then they substituted in 5 for the x. The x1 they put in a 5, and they used -6 in for the y1. Then they took the time and they simplified it, and they ended up with y by itself, 2/3 x, so 2/3 is the slope of the new line minus 28/3, which 28/3 would be a -28/3, would be like -9 1/3. That would be your y-intercept. And you can see over in the, draw a line here, this new line here has a positive 2/3 slope, and it goes through at -9 1/3 because that's the y-intercept. So the final answer you want to put in slope-intercept form, even though we use point-slope form to begin with. Now I like to use point-slope form very, very little. I use slope-intercept form almost all the time to manipulate and get information to find the y-intercept, to find, whatever I need to find. So you'll see that in class. Thank you. Actually, take another minute here. I'll do this next example, guided practice number 4, and I'll use the method I like to call using the slope-intercept form. So this one, we're supposed to write an equation, slope-intercept form, and the line has to pass through that 0.37 and has to be parallel to this line right here that has that equation. So they're going to be parallel. I know the slope has to be the same as this one. So my slope is going to be 3/4. So I know m equals 3/4. So right away, my new equation in slope-intercept form is going to have 3/4 for the slope. Now remember, in slope-intercept form, you have mx plus b. M is the slope, b is the y-intercept. I don't know the y-intercept, so I use this form with this point here, one of the points I know, to find out what b is. So watch how I do that. I take the 3 and I substitute in for the x. Then I take the 7 and I put it in for the y. And here's what I get. I paused the video and I filled in the 3 for the x, the 7 for the y. I multiplied 3/4 times the 3. I got 9/4. Now all I got to do is subtract 9/4 from both sides and I find out what my y-intercept is. So I'll pause it and I'll do that. So reading my sloppiness here, I subtracted -9 or -9/4 on both sides to get b by itself here, and I'd end up with 19/4, which ends up being 4 3/4 equals b. So my y-intercept is 4 3/4. When I go to write the final answer, I know my slope is 3/4, my y-intercept is 4 3/4. So all I do is put y equals 3/4 x, and my y-intercept is 4 3/4. And that would be my final answer. A little crazy. Not all the ones we do are going to be that crazy with a y-intercept of 4 3/4. You could keep it as 19/4 improper also. So that's it. So make sure you review how to find perpendicular line equations or parallel line equations. And remember to focus on the slope that we talked about here. Thanks.